So we're going to continue on with reference angles today and using reference angles. Tomorrow we will be doing, we'll probably get you up and moving about the room on the vertical whiteboard as opposed to the individual whiteboards that we've been doing lately. I think that's what tomorrow's is. And then Tuesday coming back next week, Tuesday, we'll be doing a quick solve type of thing. For those of you that don't know what a quick solve is, we'll explain it to you all on Tuesday. And you can work on that. Do that on Tuesday and get questions answered and all that fun stuff. Wednesday of next week, we're going to graph the sine function. We're going to go through and we're going to graph the sine function on Wednesday. And then Thursday, we actually might even get the cosine too on that one also. And then Thursday of next week is your test, which means that your Brown homework packet is due next week, Thursday. Your formative corrections on the formative that you got back earlier this week, those are due on next week, Thursday, right here. And I think that's all that we got due next week, Thursday. Okay. I also remind you that your unit circle project due date is the 3rd of December, which is not very far away because that's the Tuesday after Thanksgiving break. Okay? Any questions on any of that stuff so far today? All right, let's dive into it now. We are in your white packet, your note packet. Looks like the middle of the page of where we left off yesterday. Theta is in standard position with the terminal side of theta through the point x comma y. And sine, cosine, or we need to find sine, cosine, sine. That should be a tangent in there. It should be a sine, cosine, and tangent there. Who are we going to blame? Schmeling. Sine, cosine, and tangent. And we want to find actual theta. Okay? So I'll do the first one with you, and then you guys can do the second one on your own just as a test to see what you can do. Okay? So I'm first going to start with a Cartesian coordinate system, and I'm going to place on it in which quadrant is the point -5, 12. Quadrant 2. Closer to the horizontal of quadrant 2 or closer to the vertical? Closer to the vertical, right? Because we get 5 to the left and 12 up. So that would be kind of like up in here, right? So if that's where the point 5, -12, oops, wrong way. Hand was in the way, couldn't see which one was which. If that's where the point -5, 12 is, then this is actual theta here, which would make this then be reference angle theta prime. Okay? So the tangent of theta prime is going to be, if I break out my triangle that I've got going on here, this side is 5, this side is 12, and theta prime is there. So the tangent of theta prime would be 12 over 5, which means that theta prime then is going to be the inverse tangent of 12/5. Clear, inverse tangent, 12 divided by 5. I get theta prime here is 67.38 degrees. We can also run the Pythagorean theorem on this and get that the hypotenuse there is 13.
5, 12, 13 is a Pythagorean triple. If you don't know that yet, probably want to get that one memorized. 3, 4, 5, 5, 12, 13, 8, 15, 17. Okay, all, and then like if you multiply all of them by a number, then all those would be ones too. 6, 8, 10, all different Pythagorean triples. Okay? So if that's my triangle, that's my theta prime, then my actual theta, because I am in quadrant number 2, actual theta is going to be 180 degrees minus my reference angle, theta prime. So actual theta is going to be 180 minus my answer, 112.62 degrees. Really, it's 0.6198649. So the things that we can say here are actual theta is 112.68 degrees. The sine of theta would be the opposite over the hypotenuse. That would be 12/13. The cosine of theta is going to be -5/13. And the tangent of theta is going to be -12/5. Add 2 up here. Oh, did I put 6, 8? I'm sorry, I was reading the 8 from there. Yes, good catch, Chad. My fault. Questions, comments, concerns, clarifications?
Why is it 12 negative, not 5?
Because the whole fraction is
duh.
negative. Tangent, because we're in quadrant 2, so tangent's negative.
Yeah.
You now do theta, sine of theta, cosine of theta, tangent of theta, if the terminal side goes through the point -3, -4. Okay. Which quadrant are we in? Third one? This is actual theta. This is reference angle theta prime. So if I'm looking at the triangle, this side here is 3, this side here is 4, and this side is 5. Theta prime is there. 3, 4, 5 is a Pythagorean triple. Okay. So then I would say to myself, the tangent of theta prime is 4/3. So theta prime would be the inverse tangent of 4/3. The inverse tangent of 4/3 is 53.13. Because we are in quadrant number 3, actual theta is going to be 180 degrees plus my reference angle. So that is going to be 233.13 degrees. Sine is going to be negative 4/5. Cosine is going to be negative 3/5. Tangent is going to be 4/3. Questions, comments, concerns, clarifications? Things that you should know in terms of if theta is going through a point and r is the distance from that point to the origin. Okay, it's just Pythagorean theorem. X squared plus y squared square root. Okay, get to that one. So we're going to call that r. So if we have that, then the sine of theta is going to be y over r. Which means the cosecant of theta would be r over y. The cosine of theta is going to be x over r, which means the secant of theta is going to be r over x. The tangent of theta is going to be y over x, which means the cotangent is going to be x over y. The kicker here is that theta prime, your reference angle, I don't like how I spelled how the E came out. Is going to be the inverse tangent of y over x. But if you'll notice what in all of the examples that we've been doing so far, we have always done the positives. We've always done it off of the triangle. So now that we're just giving you a point, there is one condition to that, just to the reference angle, and that is that you drop any negative signs. So you drop any negative signs in that one, so you're only dealing with quadrant 1 tangents. Very useful slide for you. Okay. Find the cosine and the tangent and the theta if the sine of theta is 3/5 and the secant of theta is positive. Two conditions here. Why did we have to give you a second condition? Now we've narrowed it down to the one answer that we need. Right, Mr. Stackbauer? Okay. Stacky knows. Okay. So where is sine positive? quadrants 1 and 1 and 2. Okay. Where is secant positive? Quadrant 1, right? Everything's positive in quadrant 1. Find me the quadrant 1 angle to go along with that.
Oh, disrupting your class. So there's many of my former students in Corinthian here. I wonder if they remember the lesson about agreeing if you don't know what was said to you.
Oh, yeah.
See, Mr. Steckbauer just walked out of the ramp and turned around and said, "Oh, that was dangerous."
That was dangerous. He just
I have
agreed to
no
whatever I
That's what
said.
he said. I have no idea what I just agreed to.
He just agreed we could all go home today, for all we know.
Nice.
Good job, Lynn.
Yes. So we're in quadrant 1, right? So draw yourself a quadrant 1 triangle. Which means that theta is here, correct? Theta is its own reference angle in quadrant number 1. We learned that yesterday. If the sine of theta is 3/5, which side length is 3? Horizontal, vertical, or diagonal? If sine is 3/5, which side is 3? Horizontal, vertical, or slant? Vertical. There's got 3 sides of a triangle. We got a horizontal side, we got a vertical side, and we got a slanted side. Which one's 3? Vertical one is 3. Which one's 5? Which one's 5? The slant. Because there's my right angle. Sine is opposite over hypotenuse. No, I'm talking about this. That's why that shade is still down. Okay, what's my missing side? 4. Pythagorean triple. So what's my cosine? What's the cosine of theta? What's cosine of theta?
Oh, it's 4 or 5.
4 over 5. What's the tangent of theta? 3 over 4.
Yeah.
Yes? So theta then that's all it asks us to do. It asks us to find the cosine, the tangent, and theta. Okay? You try that one. So it's asking us to find cosine, cosecant, and theta, right? Without doing anything, I can find one of those. Which one can I find? Cosine. Why can I find the cosine? It's not opposite.
Reciprocal.
It's the reciprocal. So the cosine of theta is the reciprocal of the secant of theta. So the cosine of theta is 2/5. Without doing anything, I can do that. Now, that makes it easier, right? Okay, where is cosine positive and sine negative? Quadrant 4. So let's draw ourselves a quadrant 4 triangle. This is going to be actual theta. Oops, I almost put theta prime. This is going to be actual theta. This is going to be theta prime because I'm not in quadrant 1. Okay. Cosine is what? Adjacent over hypotenuse. So this is going to be 2. This is going to be 5. Is that a Pythagorean, start of a Pythagorean triple? Nope, so I got to do the actual Pythagorean theorem on it. So 2 squared plus b squared equals 5 squared. 4 plus b squared is 25. B squared is 21. B is the square root of 21. Right? Okay. Can I find the cosecant now? Yeah? I would say here that the cosecant of theta is 5 over the square root of 21. Would you agree with that?
Yeah.
Do you agree with that? Because the sine of theta, right, is square root of 21 over 5. So the cosecant should be 5 over the square root of 21. Do you agree with that? Does anybody not agree with that? Does anybody not agree with that? Does anybody not agree with that? Why don't you agree with it? Nope, we can have square root at the bottom, we're not on a unit circle. No, those are 100% the right numbers. Nope. What's wrong? Why has it got to be negative? Which quadrant are we in? We're in quadrant 4. It's got to be negative. Sine and cosecant are negative in quadrants 3 and 4. So we can't forget that. It's got to be negative. Okay. Now we just have theta to find. So my reference angle is going to be the inverse tangent of opposite over adjacent square root of 21 over 2. Inverse tangent 21 close bracket divided by 2 gets me 66.42.
Could you just find that with the opposite of the cosine right away?
With inverse cosine? Yep. But because we are in quadrant number 4, actual theta is 360 degrees minus my reference angle. $293.58. Yes? I'll give you a mod to work on your homework, but I expect you to be working on your homework during said mod.